Hello and welcome. This is Dr. Hasan Mehboob, working at SR University Warangal as an assistant professor in the Department of Mathematics, School of CS and AI. In today's lecture, we are going to discuss about basics of probability. By the end of this session, you will understand the concept of probability. You will be able to identify random experiments and outcomes. You will be able to find the sample space and outcomes for simple experiments like tossing coins, rolling dice, and drawing cards. You will be able to calculate probability using formula. You will be able to solve basic probability problems involving events addition rule and events multiplication rule. So let's begin today's lecture. So what is probability? Probability is a way to measure how likely something is to happen. It tells us the chance, it tells us the chance of an event occurring. So it is a number between 0 and 1. It is a number between 0 and 1. So probability of an event cannot be greater than 1. Probability of an event cannot be greater than 1 and cannot be less than 0. So probability of an event always lies between 0 and 1. 0 means if the probability of an event is 0 means the chance of occurring the event is 0% chance. It will never happen. Impossible event. And 1 means the probability of an event 1. It means the chance of occurring the event is 100%. So it will always happen. It will always happen. Certain event. So the closer the number is 0, if the probability of an event is closer to 1, if the probability of an event is closer to 1, so then we say the more likely the event is to happen. Concept by one example. So let's say a weather forecast says there is a 70% chance, there is a 70% chance of rain tomorrow. So in probability we write it as 0.7, 70 by 100. So 0.7, so probability of rain tomorrow is 0.7. So this means it is more likely to rain than not rain. It is more likely to rain than not rain. So but it is not certain, there is still a 30% chance of no rain. Let us consider one more example, tossing a coin. So what happens when we toss a coin? What happens when we toss a coin? So when we toss a coin, it can land in two ways. In two ways, head or tail. So head may come up or tail may come up. There are two possibilities. So what do you want? What do we want? We are interested. We want the coin to show head. We want the coin to show head. We are interested in getting head. So what we do, we count the total number of possible outcomes. So total how many outcomes? The total possible outcomes. So head or tail. There are two possibilities, head or tail. So total outcomes 2, and then we find the total number of favorable outcomes. So we are interested in getting head, so only one possibility of getting head. So one possibility of getting head, so one possibility of getting head, and total number of possibilities, total two possibilities. So 1 by 2, 1 by 2. So probability of getting head is 1 by 2, which is 0.5, so 50%. So head and tail both have the same chance, this is the basic idea of probability. Counting favorable outcomes divided by total outcomes. Now come to the definition of random experiment. So an experiment in which all possible events are known in advance, but none of them can be predicted with certain, and there is equal possibility for each result is known is known as random experiment. So a random experiment is one where we know all possible outcomes in advance, but we cannot predict which one will happen. Which one will happen? For example, tossing a coin. We know it. We know it. We know it can be heads or tails. It can be heads or tails, but we don't know which. But we don't know which one will come up. So rolling a die, or drawing a card are random experiments. But adding 2 and 3, you can see adding 2 and 3 is not a random experiment. Is not a random experiment because the result is always 5. This is deterministic. This is deterministic. Now come to the next definition, outcome. So the result of random experiment is called outcome of experiment. Outcome of experiment. So tossing a coin, two outcomes, heads or tails. Tossing two coins, so four outcomes, heads or heads tails, or tails heads or tails tails. So rolling a die, six outcomes, one or two or three or four or five or six. Sample space. Now come to the definition of sample space and events. So the sample space is the set of all possible outcomes. Sample space is the set of all possible outcomes. All possible outcomes. Each element, each element of sample space is called sample point. So each element is called sample point, and the number of element in sample space is denoted by ns. In general we denote sample space by s, and the number of elements is denoted by ns. Number of element is denoted by ns. So rolling a die, the number of possible outcomes. So set of all possible outcomes, 1, 2, 3, 4, 5, and 6. So S. So rolling a die. So this S is sample space. Tossing a coin. So when we toss a coin, so there are two outcomes. So the set of outcomes, this set S is sample space. So tossing two coins, so four possibilities. So this set S is sample space. Drawing a card from a deck, so from playing cards, so sample space all 52 cards. But here are some incorrect examples. 1 comma 2, 1 comma 2 comma 2 comma 5 has repeated elements, so it is not a proper sample space. It is not a proper sample space. Similarly, h comma h is wrong because it repeats heads. It repeats heads. So a correct sample space should list each outcome only once, like heads or tails. For a coin toss, for a coin toss, 1 comma 2 comma 3 comma 4 comma 5 comma 6. So let us understand events. So what is event? An event is a subset of sample space representing one or more outcomes. So an event is a subset of sample space. In general, we denote it by E, representing one or more outcomes. So it contains one or more outcomes. So in rolling a die, an event could be, so getting an even number, getting an even number, getting an even number is an event. So here this event is 2 comma 4 comma 6. Tossing a coin, getting heads. So event, this is event. Drawing a card from deck, so getting a red card is an event, is an event. So now come to the types of events. Come to the types of events. So elementary event a subset of sample consisting of single element is called uh, elementary event, is called elementary event. Every sample point of S, every sample point of S forms an elementary event. For example, suppose that uh, tossing a coin, tossing a coin. So tossing a coin, sample space 1, 2, 3, 4, 5, 6. So each sample point is representing elementary event. Each sample point 2, so this sample point 3, each is representing elementary event. Occurrence and non-occurrence of an event. So after conducting a random experiment, if the experiment belongs to subset E, then we say event E has occurred. If outcome does not belong to subset E, then we say event E has not occurred. Suppose that tossing a coin, suppose that event is 2 comma 4 comma 6, where event from sample space s tossing a coin. So if we toss a coin and if the result is 4, then we say e occurs because 4 is in E. If the result is 3, then E does not occur because 3 is not in E. 3 is not in E. So what is sure? What is sure event? So sure event, an event which contains all the sample points of sample space S, is called sure event. Sure event. Here the same E. So if E is equal to S, then E is called sure event. For example, when a fair die is rolled, so the sample space S is set contains numbers from 1 to 6. So if we define event E as getting a number between 1 and 6, getting a number between 1 and 6, then E contains all elements. Getting a number between 1 and 6, so E contains, so definitely E contains all 1, 4, 5, 6. So here this is equal to S. So this event contains all possible outcomes of the experiment and therefore always occurs. So hence E, so here E is sure event. Impossible event, an event which does not contain any sample point of sample space, is called impossible event. For example, when a fair die is rolled, the sample space, we know the sample space S set contains numbers from 1 to 6. So the event of getting the number 7 has no sample space because there are six faces in a die. There are six faces in a die, and faces total six faces, 1 2 3 4 5 6. So 7, event of getting 7 has no sample point. So this is impossible event. Complementary event. So the complementary event of an event S is the set of all outcomes in the space S that is not in E. The complementary event of an event E of an event E is the set of all outcomes in the space S that are not in E. Mathematically, it is denoted by EC, which is S minus E. So when a fair die is rolled, so the sample space is from numbers from 1 to 7. If the event is getting even number 2, 4, 6, then the complementary event consists of all outcomes not in not in E, not in E. So 1, comma 3, comma 4. So this is complementary. This is complementary of this E. This. Now come to the formal definition. So formula of probability. So the probability of an event is defined as the number of favorable outcomes divided by the total number of outcomes. Favorable outcomes are those where the event occurs, where the events occur. So total outcomes are all possible results in the sample space. So this formula is the foundation of everything, foundation of everything in probability. So where P is called the probability of an event E. If P of E is 0, then event E is impossible. We have already discussed. For example, if we want to find the probability of getting one head and one tail when tossing two coins. So there are two favorable outcomes. When tossing two coins. So we get uh, head head, or head tail, or tail head, or tail tail. So favorable outcome, one head and one tail. So one head and one tail, we can see there are two outcomes. There are two outcomes that are having this property. One head, we can see here one head, one tail, and here one tail, one head. So total favorable outcomes, two favorable outcomes, and total number of outcomes, total four outcomes. So 2 by 4. So 1 by 2, which is 0.5. So probability of getting one head and one tail is 0.5. Now come to the some probabilities of getting 3, getting even number, getting 7. So when we roll a die, so sample space is 1, 2, 3, 4, 5, 6. So probability of getting multiple of 3. So multiple of 3, how many outcomes are multiple of 3? We can see this outcome multiple of 3, and 6 is also multiple of 3. So how many favorable outcomes? So 2, 3 and 6. So total two outcomes are favorable. So total two outcomes are favorable outcomes divided by total outcomes. So total 6. So 2 by 6, 1 by 3, 1 by 3, which is approximately 0 point, which is 0.33, sorry, which is 0.33. So probability of getting multiple of 3 is 0.33. So probability of getting an even number. So probability of getting an even number. So how many outcomes, how many numbers are even? So here we can see 2 is even, 4 is even, and 6 is even. So total 3 numbers are even numbers. So favorable outcomes 3, and total number of outcomes 6. So 3 by 6, 1 by 2. So probability is 0.5. So probability of getting an even number is 0.5. So probability of getting the number 7, probability of getting the number 7. So we can see there is no outcome, there is no outcome 7. So here total number of favorable outcomes, so 0, 0 by 6 is 0. So now come to the another concept, another concept, equally likely outcomes, equally likely outcomes. In many experiments, outcomes are equally likely, meaning each outcome has the same chance of occurring, has the same chance of occurring. For example, in a fair die, in a fair die, each phase has probability 1 by 6. Each phase has probability 1 by 6. Because in a fair die, when we roll a die, so we get 1, 2, 3, 4, 5, 6. This is sample space. So probability of 1, probability of getting 1, probability of getting 1, this event, this is event. So probability of this event is here number of favorable outcomes, so only 1 by 6. And probability of getting 2, probability of getting is getting 2 is probability of getting 2 is, so total favorable outcomes, so only one favorable, and total number of outcomes 6, so 1 by 6. Similarly, probability of getting 3 is 1 by 6. So here we can see each outcome has same probability 1 by 6, 1 by 6. So equally likely outcomes. So these are equally likely outcomes. So probability of each outcome in equally likely outcomes, so 1 by number of outcomes. Now come to the example of die. So rolling a die. So this is not example, this is explanation of equally likely outcomes. So here probability of 1, probability of 2, probability of 6 are same, are same. So now come to the first example, first problem solving example. So a fair six-sided die is rolled. So what is the probability that the number rolled is divisible by 3 or 4? So a favorable, when we rolled a die, so number of outcomes, so number of outcomes 1, 2, 3, 4, 5, 6. So set of all outcomes is called sample space. So this is sample space. So what is the probability that the number rolled is divisible by 3? So first event, suppose first event 1 is number divisible by 3. Number divisible by 3. So here we can see how many numbers are divisible by 3. 3 is divisible by 3 and 6 is divisible by 3. So E1 is 1, and E2, suppose that E2 is number divisible by 4. So how many numbers are divisible by 4? So we can see only 4 is divisible by 4. So E2 contains only 4. So total number of favorable outcomes, total number of favorable outcomes, total number of outcomes, favorable outcomes getting 3 or 4. So here total 2 outcomes and here total 1 outcome. So total number of favorable outcomes 3. So probability of getting 3 or 4, total number of favorable outcomes, so favorable outcomes 3 and total number of outcomes 6. So 3 by 6, 1 by 2. So probability is 0.5. probability of getting probability that the number rolled is divisible by 3 or 4 is 0.5. Now come to the next problem solving example. So here we roll two dice. Suppose that a fair six-sided die is rolled twice. Is rolled twice. So what is the probability that the sum of the dice is either 7 or 11? So when we roll a die twice, when we roll a die twice, so we dice twice. So possible outcomes, total number of outcomes, 6 into 6, 36. 36. So possible, first on first die we can get 1. So we start from 1, 1 comma 1 we can get 1. On second we can get 1, 1 comma 2, 1 comma 3, and 1 comma 4, 1 comma 5, 1 comma 1 comma 6. So this first position, this shows number on first die, and this shows number on a die in second time. Similarly, 2 comma 1, 2 comma 2, and so on up to 6 comma 6, up to 6 comma 6. So total number of outcomes 30, total number of outcome 36. So what is the probability that the sum of the dice is either 7 or 11? Either 7 or 11. So sum of the dice 7, 7 or 11. So possible outcomes, so 1 comma 6, 1 comma 6, 1 comma 6, 1 plus 6 is 7, and 6 comma 1, 6 comma 1, 2 comma 5, and 5 comma 2, 5 comma 2, 4 comma 3, 3 comma 4, 3 comma 4. So how many? 1, 2, 3, 4, 5, 6. So we can see here sum 1 plus 6, 7, 6 plus 1, 7, 2 plus 5, 7, 5 plus 2, 7, 4 plus 3, 7, 3 plus 4, 7. Total 6, and sum is 11. Sum is 11, so possibilities 5, 5 plus 6, 11. So 5 comma 6, 5 comma 5 comma 6, and 6 comma 5, 6 comma 5. So here total how many? Total 6 possibilities, and here total 2 possibilities. Total 2 possibilities. So total number of favorable outcomes. So sum is 7 or 11. Sum is 7 or 11. So we can see these two events are mutually exclusive. Mutually exclusive means intersection. We can see intersection is empty. So total 8 favorable. So probability of uh, getting some 7 or 11, total 8 by 36. So 8 by 36, 8 by 36, which is, so probability is 0.22. Similarly we can find, suppose that we are interested to find probability of getting sum 12. So probability of getting sum 12. So sum 12, how many favorable outcomes? So sum is 12. So only one possibility, 6 comma 6. 6 plus 6 is 12. So probability of getting sum 12, is total number of favorable outcomes 1 by 36. So this is probability of getting sum 12. Similarly, probability of getting sum suppose that 10, so 10, how many possible outcomes? So 5 comma 5, 5 comma 5, only 5 comma 5, 5 comma 5. So total 5 comma 5, sorry, 5 comma 5 and 6 comma 4, we get 6, some more outcomes, 6 comma 4, 4 comma 6, 4 comma 6, any other. So only three possibilities, only three, three outcomes. So three outcomes, so total three favorable outcomes. So probability of getting sum 10 is total number of outcomes 3 by 36. So 3 by 36, this is probability of getting sum 10. So I will stop today's lecture. So in next lecture, we will continue same topic, and we will discuss some more problems based on drawing cards, based on cards. Thank you for watching.